Example 1.2.12, convert the input power calculated in the previous example 1.2.9 into kilowatts. So we calculated it in watts. I want to convert that over to kWh instead. Sorry, kW. So given, we need to go back to the previous problem, and we just want to write down that the input power was 2000, excuse me, what was that number? Let me find it real fast. 2613.3 watts. There we go. And we just need to convert that over to kilowatts. So we're in watts and we want to put it in engineering standard notation of kilowatts. So that's the required, what is the input power in kW. So we need to use the conversion from watts to kilowatts for this solution, and that is 1 kilowatt is equal to 1,000 watts. So that's just scientific notation would be 1 kilowatt equals 10 to the third watts, and exponential notation would be 1 kilowatt equals 1 e to the 3 watts. It's all saying the same thing. Now my handwriting's not great on this because of the digital tablet. I do want you to know those watts are capital W's. The K is not, it's a lowercase w in kilowatts. So now what we need to do is just do some dimensional analysis. We need to multiply through by our fractions. So we've got 2613.3 watts, and since watts are in the numerator, we need to put watts in the denominator of our multiplicative factor. So there's 1 kilowatt divided by 1,000 watts. Now our watts cancel, and we're left with 2.6133 kilowatts. I know that was a little bit of more work than you normally would do to convert watts to kilowatts. You probably just think, well, divide by 1,000, but what I wanted to show you here was the fractional method, because when things get more complicated with energy conversions and unit conversions, the dimensional analysis or the use of fractions to do the conversion is really, really helpful.